Hi everyone, so we're going to continue with our biogeochemical cycles here with our phosphorus cycle. This is actually going to be the last cycle that we talk about. So our phosphorus is an element that's made up of many molecules that make up many cells in living organisms, just like our other couple cycles that we've talked about with nitrogen and carbon as well. Plants get the phosphorus they need from soil and water, while plants get their phosphorus by eating plants. Again, very similar to the other cycles here. So by eating plants or by eating animals that have eaten plants. So the phosphorus cycle is a cycle movement of phosphorus in the environment to organisms, then back to the environment. So something we notice here is that there's no atmospheric component here. So the movement of phosphorus really goes from the biotic and to the abiotic that are physically found on the earth rather than in the atmosphere. So this is really important that phosphorus does not have any atmospheric component. So there's no phosphorus gas that we can see here. So let's take a look at what this is going to look like. So what we see is we're going to see rain here that's going to weather the rocks and bring that phosphorus either into the water. This water is going to be used to water plants and all these different things, which we're going to see. That's how the plants might get some of their phosphorus. We also see there might be some phosphorus in the soil due to either man-made fertilization or things like that. So what's going to happen is that either these plants or animals are going to eat these plants both in the water and in the land. And when those plants and animals decompose, it's going to bring that phosphorus back into the soil or into the water here. A little bit more of an easy cycle to follow because there isn't that atmospheric component. So phosphorus might enter the soil when rocks erode. So it's mainly rocks that are going to bring this phosphorus into the soil. So it's going to dissolve as a phosphate. They move into the soil, water, and groundwater. So remember, groundwater is what we use to drink as well, so we might get some of our phosphorus from drinking water. So plants are going to absorb these phosphates from the soil to their roots. And the phosphorus washes off the land is going to end up in some water bodies. So runoff is going to play an important role here. Because phosphate salts are not soluble in water, it's going to sink to the bottom and accumulate in the sediment of the soil. So again, our plants are going to absorb that phosphorus through their roots as well, because it will be in the sediment rather than just floating in the water like we see some other salts as well. So again, looking here, we can see weathering or physical mining. So that's another man-made process here. Bringing that phosphorus into the soil, sometimes into that runoff is going to bring it into the water. We're also going to see fertilizers as a part of this man-made bringing that phosphorus into the system. We can see our soil is going to take it. It's going to go to our land plants. Our consumers are going to eat those plants, and then both plants and animals will decompose and bring that phosphorus back into the soil. Again here, same thing is happening in the water. From the runoff, the plants are going to get that phosphorus from the sediment at the bottom. Consumers are going to eat those plants. Both plants and animals will decompose, and again, that phosphorus is going to go back into the sediment or sedimentary rock in both land and the oceans. Notice up here, no arrows are pointing to atmosphere, so there's no air component. So let's talk about some of these fertilizers in both the nitrogen and the phosphorus cycles. So fertilizers are what people use to help maximize plant growth. And it's important because both nitrogen and phosphorus can be maybe a little bit more difficult to get than carbon in some cases. So it's important that we help with these plants to get these nutrients. Though excessive amounts can enter some of these different terrestrial and aquatic ecosystems through runoff. And those excessive amounts is what's going to have a negative impact here. So this is going to cause rapid growth of algae because, again, these are chemicals that are going to help grow, but those rapid blooms of algae actually have a bad cause here. So excessive algae can actually deplete an aquatic ecosystem because we're taking away all the oxygen as these plants are growing. And so since all animals need oxygen to breathe in some form, either dissolved in water or in the air, these fish are not going to get the important nutrients they need to survive. And this is actually called eutrophication. And it's a really important thing to notice that this is actually not always a good thing. So it's we want to remember that yes, fertilizers do help with that plant growth, but it's not always a good thing. So the process of when those algae blooms happen and are going to take those resources from the other animals and the fish is called eutrophication. So ETROPHI. So that's what this is called. That rapid bloom of algae is going to result in this process right here, which can be very detrimental to those aquatic ecosystems. If you have any questions, please let me know.